the difference quotient so we can write it and carve it in stone, hopefully?
F of x plus h minus f of x over h.
Perfect. Thank you so much. That was Rebecca. Thank you. Now, two steps are required when finding this and simplifying the difference quotient. Can anyone tell us the correct order and the steps? Ezra, would you like to start?
First, you plug in the function into the difference quotient.
So let's go back. When we calculate the difference quotient, two things have to happen. Two steps have to happen always. All terms without h must simplify in the numerator. The second one, that it's a must. H from the denominator must go away, must simplify. So one more time, can anyone tell us again what are they so I can put them in?
Simplify the numbers in the numerator?
No. One more time. All terms
Without h?
yes. Without h must simplify. Of course, we mean the numerator. I didn't specify, but we know that. I can put in parentheses, the numerator. If you don't know what to expect, you will have difficulties in determining the difference quotient. You will not know when you make an error. You will not say, stop, stop. I'm not getting these two. But if you don't know them, you're not going to know when you're wrong. Okay, so please careful. The terminology is so important in this class. It's like a foreign language, right? I can't start speaking a different language if I don't know some words, right? Okay, what is the second one?
H from the denominator must simplify.
Perfect. Thank you. H from the denominator must simplify. Excellent. Okay, the equivalent form of this is this, and of this is this.
Of a is it x 2 over 3?
Excellent. Thank you so much. Thank you. Awesome. What about this one? Brian, would you like to try? It's okay if you're wrong. You are muted.
I don't know this one.
Okay, let's try step by step. What do you know about it? Anything?
Don't you put 1 over 3?
Excellent. Yes, so you know a lot. Okay, very good. And now look at this and come up with this in a radical form. The index.
5.
Exactly. Excellent. That's it. So you know how to do this. Very good. Okay, now I'm ready for your questions. Thank you for your answers. Very good. I'm ready for your questions. Anything you would like to work on? Anything?
Can we do problem 2 from the homework?
Yes. What was it? Please remind me. I did not write solutions yet.
Let me go back. Let's see.
I think it was a difference quotient.
For
yes.
f of x equals 1 over x minus 3.
Good. Good. So we know that the difference quotient, if whatever color I'm using is not visible, please stop me at any point in time. So I will write f of x plus h minus f of x divided by h. There is no problem here. There is no problem here. Can anyone create f of x plus h for us?
1 over
x plus h minus 3.
Brilliant. Thank you so much. Now, can anyone determine the least common denominator for us in the numerator?
X plus h minus 3 times x minus 3.
Excellent. Brilliant. Thank you so much. You can put this over 1 so you know everything is over 1. Anything that is an integer or a number is over 1. So perfect. The least common denominator is x minus 3 and x plus h minus 3. Of course, this one needs the x minus 3. And of course, this one needs the x plus h minus 3. X plus minus 3 times 1. Careful now. Negative, negative, negative. So minus x minus h plus 3. As we just reviewed, all terms without h in the numerator, all terms without h must go away. They better, otherwise I'll say stop. So now I have the numerator, which is negative h over x minus 3, x plus h minus 3. And I have to flip, because I'm dividing, multiply by the multiplicative inverse of the denominator. H from the denominator must go away. Yes, of course. It does. So negative 1 over x minus 3, x plus h minus 3. Do not multiply the factors in the denominator. Do not distribute here. Note, again, do not multiply or expand, in other words. Oops. The factors in the denominator. This is it.
I have a question.
Please do. Yes?
So h is negative. When you cross out all the like terms, you have negative h at the top.
Yes.
Oh, I'm sorry, I didn't see it. Never mind, never mind.
So let me explain something. Negative h is the same with negative 1 times h. And if I have negative 1 over 2, I can write negative 1 over 2. And that's what I did. I took the negative 1 that multiplies h in front, so there is no confusion when I simplified. Very good question. Anything else? Do you have anything? Yes? Yes, please.
So for my answer, I got that same exact answer, but I accidentally left a negative next to the 1. Would that take any points off?
No, it's the same thing.
Okay, thank you.
We prefer this, but it's the same thing. Because you're basically dividing the sign of the top by the sign of the denominator. But if you have this, you have to be very careful. It's a different story. Don't correct anything. Of course, I'm going to white it out. But because it's only one term in the numerator and that term is negative, I will put the negative in front. But if you don't, it's still the same thing. Both are acceptable. Very good questions. Thank you for engaging in the discussion. Thank you so much. Next question. Anything else you have for me? Anything else? Okay, so I'm going to share my screen and go to the book. Share my screen. I lost you. Clicking on the different things here, I lost you. Okay, we're back. And where is my book? Now I lost my book. No, I cannot lose my book. Where is my book? I had it open. Yes, here it is. I wanted to show you something. Yes, we have to go back to R.5 in a minute. But I wanted to show you how many videos you have here on all sorts. How to graph this, how to graph that. I don't 100% agree with all their methods, but they are acceptable. Okay, so you have tons of videos as well in here. Okay, so now I want to go back to finish up R.5, and the page number is 60. How are you doing with the Pearson work? You can bring any questions to class, you know that, right? So we can move on together. I don't want to leave anyone behind.
Did we have any Pearson work due for today?
No, all you had was R.1 through R.4. If you completed that, you are on track. And that was due last week. R.5 is not due because we haven't finished. Okay, so last time we only looked at some applications of exponential rules. Okay, and domain, we already discussed domain many times already. Do you feel like working on exponential rules a little bit more, or we move on?
You can do a couple.
I'm sorry?
I would like to do a couple.
Okay, so let's choose. So can you choose?
It doesn't really matter. I'll go 55.
Okay, so we write each of the following as an equivalent expression with rational exponents. So if we look at 63, for example, on page 60, so it's 1 over the square root of x squared plus 7. Any idea on how to change this into something, a base raised to an exponent? And of course, the exponent has to be a fraction because we are talking about a root. Can anyone give us an idea how to change this? What will be the first step? Anyone?
Square.
You cannot. So let's talk about this. The square root of x squared plus 7. I think I misunderstood, but I realized what you said. So please remember, this is never the square root of x squared plus the square root of 7. You cannot write something like this. If it's a negative, the same thing. So if it's a sum or a difference under the square root or any root, you cannot write this. Also, when I have a fraction, if I have a fraction like 1/3, if I square it, I get 1 over 9, but 1/3 does not equal 1 over 9. So we cannot square. I can square if I have an equation. If this equals 4, then I'm allowed to square both sides. Yes, but I can't square a quantity. I can square both sides of an equation, but not a quantity. We are only asked to write the equivalent expression of this. We're not asked to solve. We're not asked to find the domain. We're not asked to do anything. We're only asked to write the equivalent expression like we just did a minute ago. This turned into this, and this turned into this. So we're given this, and we want to turn it into this. So how do we do that? What is the base? What is the base that I have to write here in parentheses of this expression? What is the base? What do you think? Michaela, what do you think? What is the base in this expression? What will be the base that I have to write here?
X squared plus 7.
Excellent. Excellent. Perfect. Now, what will be the power? First of all, the power has to be a fraction. Anyone who can tell us what will be the power?
1 over 2.
Yes, but negative. Awesome. Exactly.
Why is it negative?
Because it's in the denominator.
Okay.
So if I have only this, then it's x squared plus 7 to 1/2. Because the power of this is 1 and the index is 2. but it's in the denominator. And we know that only if the power is negative, the quantity ends up in the denominator. Is that okay?
But how do we come up with 1/2? Is the 2 the denominator because of the exponent, or?
Not the exponent. The exponent is the numerator. The index is the denominator.
Okay.
Very good. Okay, so let's go back. I would like us to talk about something called equilibrium point and demand and supply. So that's our page 3.
So that was the answer, just the.
That's it. That is it. So we were asked to change that expression into the equivalent expression with a rational exponent. That's all we're asked to determine.